All right, lesson 52, properties of rectangles, rhombuses, and squares. So we're talking about special parallelograms. Everything we're talking about fits inside that those four parallelogram rules, right? But we're going to talk about what makes rectangles separate from rhombuses, rhombuses separate from squares, those types of things. What do they have that are similar? What do they have that are separate and different? So all three of these things are going to have your properties of parallelograms, meaning that their opposite sides are going to be parallel, meaning that their opposite sides are going to be congruent, meaning that they're going to have diagonals that bisect each other, right? They're going to have, and there's another one in here. Oh, let's see. What was it? Consecutive angles are supplementary, right? I believe those are the four rules. Okay, opposite angles are congruent. The diagonals of parallelograms have special properties. So each of these are going to have specific diagonal properties that are specific to each other. They might be shared, but we'll know something specific about the diagonals of a rectangle that's different than necessarily the diagonals of a rhombus. Okay, so these are important rules to write down, because whenever they start to give you illustrations, and they might say, this is a rectangle. All right, solve for this part of the diagonal. Okay, well, I'm going to have to go back to what I know about the diagonals of a rectangle in order to solve for missing pieces. Or, they're going to say, hey, this is a rhombus. Solve for this. They're telling you it's a rhombus because they expect you to use the properties of a rhombus to solve for what it is that you need to solve for, or a square. So a rhombus is a parallelogram with four congruent sides. A rectangle is a parallelogram with four right angles. A square has the properties of both a rhombus and a rectangle. So just to kind of reiterate, are all squares rectangles? Yes. Are all rectangles squares? No. Are all squares rhombuses? Are all rhombuses squares? Okay. All right, so that we know and we're aware of that. That might be something I would write down, because that's not in the notes, right? Just, hey, as a reminder, all squares are rhombuses and rectangles. Not all rectangles are rhombuses. Not all rectangles are squares. Not all rhombuses are squares. Okay? No. A rhombus is only a rectangle when it is a square. Does that make sense? So that's the only time a rhombus is a rectangle, is when that rhombus is also a square, because that square is also a rectangle. Okay? So it's kind of a Venn diagram of a situation. Okay? If you know what I'm talking about there. Square shares the properties of a rectangle and a rhombus. One property of the diagonals of a parallelogram has already been introduced. They bisect each other, because they're all three of these are parallelograms, right? And the rule that we already know about the diagonals of parallelograms is that they bisect. So whether it is a square, a rhombus, or a rectangle, the diagonals will cut themselves in half, okay, into two congruent segments. Now, that doesn't mean that the diagonals themselves are congruent to each other, right? Because in a rhombus that is just a rhombus, right? It's not a square, it's just a rhombus. Those diagonals bisect, but they're not equal to each other. Do you follow me? Okay. All right. Three more are introduced in this lesson, so there's quite a bit here. Okay, properties of a rectangle. These things are specific to rectangles that are just rectangles or squares. Okay, the diagonals of a rectangle are congruent, meaning that PR is equal to SQ. The whole length of the diagonal is equal to the whole length of the other diagonal. All right, does that make sense? Meaning that if I just, let's say we add something in here, we call this point in the middle T, all right? If I knew just one half of one segment, I know something about a lot of this. So let's say that PT was 11. Okay, well, now what do I know about TR? What is TR? What is the length of TR? which is 11, right? And because the whole diagonal is congruent to the whole other diagonal, what is the length of SQ? No, what is the length of, look. Right. Don't listen to what I'm saying. SQ, right? What's the length of SQ, Chandler? 22, okay? So don't just listen with your ears, but look with your eyes, all right? What is SQ? It's a whole diagonal. It's not just a segment. So if PT is 11, that means TR is 11, which means PR is 22, which means SQ is 22. All right, so do you see how if they tell me that this is a rectangle or there's enough information to prove it's a rectangle, now I know a whole bunch of information about its diagonals. Does that make sense? So just by using the statement PQRS is a rectangle and they've shown me diagonals, I have all kinds of information available to me. Okay? Does that make sense? Do we understand how to apply this information? Okay. So if a quadrilateral is a parallelogram, it is a rectangle if and only if the above property is true. So if they're not showing me that, hey, this is a parallelogram with 4 right angles, right, that would prove that it was a rectangle. They only show me that, hey, this is a quadrilateral and it's a parallelogram, but they haven't shown me anything about its angles. I only know that it's a rectangle based upon its diagonals if this happens to be true up here, right? So if they showed me that, I would know based upon that now I can say that this is a rectangle. Okay? So this is kind of the converse of the above statement. This says, this is a rectangle, therefore this is true. Down here, this is true, therefore this is a rectangle. Okay, do we understand the difference between a statement and its converse? We did a little bit of that yesterday, but just trying to bring you back up to speed, because how many of you feel like you lost information over Christmas break, right? I got dumber over Christmas break, right? So don't take offense if it sounds like I'm talking down to you. I'm under the natural assumption that we probably forgot some stuff, okay? All right, rhombuses. Now this is true of the diagonals of a rhombus when it's just a rhombus, okay? It's also true of squares because squares are rhombuses. But the diagonals of a rhombus are perpendicular. So the rectangle dealt with congruency. This deals with slope. Okay? So if I know something about the slopes of the diagonals of a parallelogram, and I know that these two diagonals meet at right angles, now I know that this is a rhombus. Or if I know it's a rhombus, I know the relationship of the diagonals. Okay? The moment they tell me this is a rhombus, and they show me that it has diagonals, I know that they meet at right angles. Okay? Which, handily enough, if all of these are right angles in here, what do I have 4 of inside of this rhombus? 4 right triangles. And we can solve things with right triangles, right? We can use the Pythagorean theorem. We can do all kinds of different things once I see a right triangle. All right, so hold on, just looking at this. So HJ is perpendicular to IK. Okay, HJ, this line right here, is perpendicular to IK. Okay, and if we made separate T in here, I know that HT is perpendicular to TK. Okay, or that KT is perpendicular to TJ. Okay, or so on and so forth all the way around. Okay, if a quadrilateral is a parallelogram, it is a rhombus if and only if the above property is true. So if I see a parallelogram where I have diagonals and I see that they're at a right angle, but they haven't said anything about this being a rhombus, right? If I see that this is true on the inside, I know that this is a rhombus. So that's the converse of it. Okay, one says this is a rhombus, therefore this is true about the diagonals. The other says this is true about the diagonals of this parallelogram, therefore it is a rhombus. Okay, are we following along okay? Okay, not going too fast. Maddie, how are you doing in the back? You picking it up? Right, you smelling what I'm stepping in? Okay. All right. Since a square is both a rhombus and a rectangle, its diagonals share both properties at the same time, meaning a square has diagonals that are perpendicular, just like in a rhombus, and has diagonals that are congruent to each other, just like in a square. Okay, so in a square, both properties of its diagonals are true of what we see in a rhombus and a rectangle at the same time. Okay? All right, we also see something else about the diagonals of a rhombus. Okay? Each diagonal of a rhombus bisects its opposite angles, meaning that this, let's see if we take this, let's say A, B, C, and D. This line AC is going to divide angles 1 and 2 equally. Okay? It's going to bisect opposite angles. Okay? When they are bisected by a diagonal, you have 4 congruent angles that result. So angle 1 is congruent to angle 2. And that's congruent to angle 5 and angle 6. So 1, 2, 5, and 6 are all equal to each other. So we could go through here and say those as individual things. All right? We could go, okay, just like that. And contrary-wise, we have another set of opposite angles. So, okay, we would see that. All right? So we have something else there that's going to tell us about not only what the internal angle is caused by those diagonals, but what the exterior angles are working with there, which is helpful because, again, like I said, what we have being divided up inside this rhombus is 4 triangles, right? So I could see this, right, where I'm going to know some things about these angles. So if they gave me a piece of information, say down here, and maybe a piece of information up here, and asked me to solve 2 and 3, right, I could do that because I know certain things that are true, certain angles that are congruent to each other, correct? Not necessarily, because, for instance, that's a good question. Would it necessarily be like a 30, 60, 90? Well, let's take a little feature up here where I can create a rhombus. Okay. All right. That can be a rhombus, right? But I can make it, I can kind of make it a little bit, more extreme or less or whatever, right? So not necessarily, okay? The only thing we know for sure is that this angle in here is a right angle, okay? All right, so if a quadrilateral is a parallelogram, it's a rhombus if and only if the above property is true, okay? Given this information, I can now prove that it's a rhombus. Again, the original statement is, this is a rhombus, therefore these things that are going on inside are true. The converse is, if these things going inside are happening, then it is a rhombus. All right. So you guys will notice, I think the biggest part of your notes that are going to be handy to you, because you end up seeing, you have these things that are in your notes, but I tend to draw on top of these things. Do you necessarily get these pictures, right? So if I was writing notes, I would be going in and taking illustrations that were given in the notes. I would be putting them in my notes with the additions that were made in class, okay, to help myself out. Does that make sense? All right, does anybody need me to go back to anything? Okay. All right, so let's pull up at least a question or two. Let's see, we don't really need that per se. All right, so let's look at question number 3. We may need to. All right, so an artist designs a rectangular quilt piece, so we know that this is a rectangle with different types of ribbon that go from corner to corner of the quilt. The dimensions of the rectangle are AB is 10, AC This length right here is 14 inches. We want to find BX, okay? So we know that this, one, we know it's a rectangle, but we know that this red line is 14. We want to know what BX is. We want to know what the blue line is. All right? How might we solve something like that? AC is 14. The whole diagonal is 14. What do we know about the diagonals of a rectangle? Go back in our notes, right? Diagonals of a rectangle. We only really got one slide on rectangles, so that should be fairly easy to go back and find. We got two different things on rhombuses. They're congruent, all right? So they're congruent. What else do we know about a rectangle's diagonals? Because it's a parallelogram, they... Yeah, we know it's a rectangle. A rectangle is also a parallelogram, right? Okay, what do we know about the diagonals of a parallelogram? They bisect. Okay, so let me ask you about this. If we know that AC is 14, what is AX? 7. Okay, so what is BX? 7. Okay, take 14 divided by 2. That's it, right? All segments are going to be the same. Just like whenever we drew it up on the board, if I knew that 1/2 the segment was 11, then I knew that the whole segment was 22, then I knew that the individual segments of the other diagonal were 11 and 11, and the length of the whole other diagonal was also 22. Does that make sense? Okay? All right, we don't have a lot of time left. In fact, probably no time because it's an early out, right? You guys get out at what, now? Okay.